From the video, scientific notation is always going to be a number between 1 and 10 to a power from that rule. But we just want to think of multiplying by 10, 100, or 1,000, or dividing. So if we are multiplying, so please write over here that we are going to multiply by multiples of 10. When we multiply by multiples of 10, so this whole first row, when we are doing that multiplication, you could tell me, Jacqueline, that my rule is going to be to do what? We're going to move the decimal always what direction? Move the decimal to the right. Okay, so we're always moving it to the right when we multiply by a multiple of 10. And how many places, Jennifer, do I need to know how to move it? So I look at the what? Like how if I'm looking at this one, we moved it 2 places. Here we moved it once. Here we're moving it 3 places. What helps me decide how many places to move it? We're going to count the number of zeros, right? So we move the decimal to the right, and we want to count the number of zeros, if we are thinking about that. So when you multiply by 10, you only move it 1 place because you have 1 0. You multiply by 100, you moved it 2 places to the right. So counting the number of zeros is always what we want to be thinking about as we are looking at those. And so if our second part of this is what's the rule for dividing, if we are going to divide by a power of 10 or multiples of 10, if we are looking at it, Fisher, what could we say? So if we are going to, in this case, divide, instead of moving the decimal to the right, we are going to move the decimal to the left. So we're moving it to the left as we are looking at that. And we are, again, still counting those number of zeros. So instead of taking out your calculator, if you're ever dividing, which some of you are pulling out your calculators to do these, you look and there's 3 zeros, and you're going to move the decimal 1, 2, 3 places to the left, 8.73. You look at 100 and you move it 2 places by 10, and that'll work for any powers of 10 or multiples of 10 as we are looking at those. So in the video, we were looking at just simply scientific notation, but from our homework earlier, we know anything to the 0 power, 10 to the 0 is 1. 10 to the first is simply going to be 10. 10 to the second, 100, 1,000, and then we're going to go 10,000. Now, we know that 10 to the negative 1, right up above that, if you would please write that as a positive exponent. So yesterday on your quiz, we were looking for this being written as 10 to 1 over 10. We read that as 1/10, that is the decimal 0.1. So when we look at 10 to the negative 2, we know that these two should be reciprocals, right? I know that these two are going to be reciprocal. So if this is 100, 10 to the negative 2 is going to be 1 over 100. And if I am writing that as a decimal, we would read it, and as we read that one, I read it as James 1 what? We read that fraction. 100. And so we are looking at 0.01. Always have the question, do I need to have the first number, that first 0 before the decimal point? I would recommend putting it in as a placeholder so that you have that. And here's the other reason. Take a look at this number. You got a negative 1, you have 1 0, even if that 0 is in front of the decimal point. When it's 10 to the negative 2, you have 2 zeros. One of them is in front of the decimal point, one of them is behind the decimal point. So 10 to the negative 3, we know that that's going to be the reciprocal of 1,000. So we know that this is 1/1,000. And if you think about that 0 point, I need a total of 3 zeros, counting the 1 in front, and then a 1. So again, knowing that 10 to the 4th, if you were writing this down, is going to be 1 over 10,000. Looking at the number of zeros, 0 point, we have a total of 4 zeros and then a 1. This is the 4th place back, 1, 2, 3, 4. So that's where our number goes when you are taking a look. If you think of Super Bowls, that's where a lot of times Roman numerals are written, and when they talk about what year of the Super Bowl it is. Today we're going to look at some other forms of writing our numbers. So decimal notation, often in your homework called standard form. It's the regular way of writing numbers. I would like you to put down the number 2,500. I would also like you to put this decimal 0.0025. So we're going to look at both of these, and then we are going to write them in scientific notation. Now, in that video that we watched at the beginning of class where it kind of had that song, they were kind of always saying scientific notation is always going to be A times 10, it said, to the B. And the key thing with this A in that video, it is always a number. A is always going to be a number between 1 and 10. It can never be greater than 10, but it has to be bigger than 1. So when I look at scientific notation, what I would like you to put in your notes for scientific notation is you are going to write down a number that is in product form. Product form. That means you have to show this multiplication. That's what product form means. So you are going to have a number in product form by a multiple of 10, written as a power. So 2,500 is 2.5 times 10 to the third. So thinking of that, thinking that we always have to write it as a number between 1 and 10 times 10 to a power, we're going to look at this number, 0.0025, or we'd read this as 25 thousandths if we are looking at that. Or 10 thousandths as we look at it, we're going to write it as 2.5 in scientific notation. So the number always has to be first between 1 and 10. So 2.5 is between 1 and 10. If I had 25 or 0.25, that would not work. Then I'm going to have times 10, and I'm looking how far do I have to move my decimal to get between the 2 and the 5. And I'm moving it 1, 2, 3 places. But because this is a number that is less than 1, but greater than 0, this will be a negative 3. So please make sure you have both of these two down. It is always going to be in product form, always times 10 to a power. Notice that your power, if this is a small number, is negative. And if you have a large number, larger than 1, this is going to be positive. Okay? So some of you didn't write down these examples. For both of them, we're going to put both of them. You want to put this one too. That's why I put it in the writing. Starting sometimes in decimal notation. This is also considered your standard form. So please write standard form about that. So if I ask you in your homework tonight to write it in decimal notation or standard form, that means the same thing. It means just writing it as a regular number as we look at it. The scientific notation part, what I want you to put is right behind that scientific notation part, is that you're going to have a number times. This number has to be between 1 and 10 times 10, and then it's going to be a power. Okay? So notice the scientific notation for 45,000 is 4.5. And if you think here is your 0, and to move it to get between the 4 and the 5, we moved our decimal point 4 places, so 10 to the 4th. 240. We are looking at 240. As we take a look at 240, as I look at that, Grace, I'm going to have 2.4. How many places am I moving my decimal point to get between the 2 and the 4? So times 10 to the second. If I have 8.5 times 10 to the 3, Lisa, that's going to be telling me that I need to move from this 8.5, I need to move my decimal point over 3 places, which would give me 8,500. And if you're not sure when you're doing that, start here, and if right behind that, put 1, 2, put those little loops to help you to show. So this next one is we are taking a look at, Nick, first number has to be between 1 and 10, so where are you going to place the decimal point? 3.4. If I get 3.4, Michaela, I'm going to have times 10 to the 6. What I would like you to do right now is for the last 5 on here that you are looking at, or the last 4 that you are looking at here, write down and try it, and then I'm going to have you, then we're going to take a look. And then you'll be asked to change it from decimal notation to scientific. So if we are taking a look at this one, Amy, what did you have for 5.1 times 10 to the 4th? 51,000. Ashton, if we were looking at 7,250, you rewrote it in scientific notation as?
It would be 7.25.
7.25. So you got to have all the digits besides the 0 times 10 to the? 3. Olivia, if I'm taking a look at 1.5 times 10 to the 3rd, that is going to be 1,500. I am moving my decimal 3 places. Julia, if I'm looking at 360, it should be in scientific notation. Yes. Okay. Questions on doing any of those? Most of you seen. So your homework, you'll have some large numbers, and you'll write them in scientific notation. You'll have scientific notation with a positive exponent, and you'll change it to standard form. So again, scientific notation, the first number has to be between 1 and 10. Okay, so this first number is between 1 and 10 times 10 to a power. I want you to take a look that everyone here is negative, and every one of our decimal notations is a number that is between 0 and 1. So when we take a look at this, we had 7.5. So we're going to place the decimal here. And someone said if we look at the number of zeros, so if you keep the 0 in front as a placeholder, that's 1, 2, 3 zeros, 10 to the negative 3. So when I look at this next one, we're going to have 5. And when I write this, I don't care if you put 5 or 5.0 times 10. And again, it helps to count the zeros when it's a decimal. You cannot do this when it's a large number. You can't count the zeros behind it, but here you can count the 1, 2, 3, 4 zeros, 10 to the negative 4. The other thing you could count is how far you moved your decimal point, which you are moving it 4 places, so it's negative. When I look at 7.8 times 10 to the negative 5, Audrey, I'm going to be looking at how many zeros, including the placeholder? 5. So I have the 0, 1, so 1, 2, 3, 4, 5 zeros. So 4 behind the decimal point, 1 in front of it, and then I'm going to put the numbers 7, 8. Okay? So what I would like you to do is for those last 5 that you are taking a look at, try those, and then we're going to check. Kevin Murray, as we're taking a look at this one, the first number has to be between 1 and 10. Where are you going to place your decimal? Between the 5 and the 2. So I get 5.2. It's going to be times 10. How many to what place value? Negative 1. I have 1 0. I'm moving it 1 place is how we want to think of that. Okay. As we are looking at the next one, 2.9 times 10 to the negative 1. James S. What are you going to have?
0.0003.
So we're going to have a total of 4 zeros. 1 is our placeholder, 3 more, 2, 9. You are moving the decimal, if you think of this, 4 places over. So when you move it 4 places over, you have 3 zeros before. If we are looking at the next one, Evan, we should have 10 to the negative 3, looking at our total number of zeros. Jennifer, looking at the next one.
0.0026.
So a total of how many zeros? Yep, so I got 4 zeros and then the 2 6. Keeping in mind that placeholder. If I'm looking at the last one, Julia, we're going to have 10 to the negative 2. So notice all of these were numbers between 1 and 10, or between 0 and 1. And your exponents for all of these were negative. On the page before, you had all numbers that were greater than 1 in standard form, and all of your exponents here are positive. So that next page down in your notes, they're asking you to describe a pattern. And I know some of you have a hard time writing when I put this up, so I'm not going to do my writing. You can read this probably a little better, but start copying. So what you want to write down is this part. So when you are taking a look, you want to put from standard form, you move the decimal point to the left. So from standard form, you're going to move your decimal point to the left to get a number between 1 and 10. So that scientific notation is always a number between 1 and 10. You are going to always have a positive exponent as we are taking a look at that. So when we are taking a look at that positive exponent, the positive exponent, anytime we have a large number. So positive exponent for numbers bigger than 1. The second part of your notes that you want to write down is describing the pattern in that second table is when we have really small numbers. When I have really small numbers, what we are taking a look at, numbers to change it from standard form, the decimal is moved to the right, always a number between 1 and 10, but now you're going to have negative exponents. Negative exponents are used to represent numbers that are smaller than 1. So a portion of your homework tonight is going to ask you, is the number in scientific notation bigger than 1, greater than 1, or less than 1? The key thing that decides is not the number that's written between 1 and 10. What helps you decide if it's a larger number is if it's a positive exponent, then it's going to be a number larger than 1. If the exponent is negative, you're going to have a number less than 1. And it's usually actually between 0 and 1 when we are taking a look at that. Okay?